Does completing tasks in chunks change the time for the computer to complete them? What is chunking? Chunking is when you take a task and you split it up into different parts instead of doing it all at once. Taking an hour-long task and splitting it up into half-an-hour tasks, 20-minute tasks, or 6 10-minute. Here is my claim. I am claiming if I take a task and split it up into smaller chunks, the computer will be able to complete it. How I'm testing it. I'll be testing it with the Fibonacci sequence. This is when you take the last two numbers of the sequence and add them up to get the next. Start off with 0 and 1, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 5, 8, 13, 21, and so on. How I'll be using this test set is I'm going to calculate the first million digits of the Fibonacci sequence for different methods. As a baseline, I'll be doing it on no chunking, so it's just one chunk of doing all 1 million all at once. My second one will be a 10K method, which is I'm doing first million in 110K chunks, and then the 5K method, which is 5K 200 times, then the 1K 1,000 different. Here's the code I used in order to have the computer test and do the Fibonacci. So it starts out with start equals time it dot default underscore time. Basically, that the time it function just it loads a integer of how many seconds it's been since a set point in time in, I believe, the 70s. Just a number of seconds, and then start is just a variable. And the stop variable is the same thing, and it's used to get the difference in the two, so we know how much time passed. For the actual math part of it, I said in the last slide that if you take the last two digits of the Fibonacci sequence, add them up, you get the new one. 1 equals 2. So, for the example, 1 plus 1 equals 2. A is 1, B is 1, 2. That's the next one. We need 1, 2. So, you need to shift the A and B values to the most current variables. So, in order for that to happen, the B needs to become A, and whatever C is needs to become B. Next time it can be 1 plus 2 equals 3, and then become 3, A become 2. So C equals A plus B, that's getting the value of C, and A equals B shifts B over into the A, and then C equals, or B equals C shifts the C over. You can do the math for it. Here is all of my data points in here just to show how much data it is. I do not know specifically how many data points this is, but for I did 10 trials for the categories, and each of the categories were giving me some of them were giving me 100 values each, which is 1,000 values, 10 trials, but then 1,000 was 1,000 different data points over 10 trials, which was a lot more. So adding it all together, I don't know specifically how many data points it is, but this is why I'm not going to be going over every data point, just because there's an ungodly amount of them. But here is some of the data points. These are average data points, and I picked just 100K intervals. If looking at these, kind of like a preliminary assessment of them, it does appear for most of it, the 1 million is taking longer. First one, the that are being chunked almost a second longer, and then the 200K, first one, but it is about 0.2 to 0.3 seconds longer. And then the 300K, it's again about 0.3 to 0.4 seconds longer. And there's the comic trend throughout it. For most of them, it is beating the rest of them. This trend does break at 500K, when the 5K is actually, for some reason, 3 seconds longer than the other trial around it, and then it's only about 2.5 seconds longer than the 1 million. But then at 600K quickly is back under 1 million. So preliminary data does say, there is some evidence to say the one chunking does somewhat help. Some of my data points are here. They are in 100,000 milestones up to 700,000. Looking at the data points, it does seem fairly consistent that the 1 million is taking slightly longer than the other data points, the 10, 5, okay. So that this is just a numerical representation of larger milestones than what I recorded. Here is my graph of all of my data points. As you can see, up to the about 300,000 mark, they're fairly indistinguishable. You can kind of see that blue and green are separating those in the middle earlier, but that's when the main separation is. And that goes on till about 60 or 600,000 when the red starts to pop up above the yellow, and then it changes again around the 800,000 when the blue starts to go back and forth between below the yellow and above the red. And when it ends, the 10K is finishes last, the 1 million second last, the yellow finishes second, and the green finishes first. In conclusion, breaking up the task into smaller chunks does appear to have a slight difference on how long it takes to do it, but the difference is not enough to be sure it's not error. And when the task is broken up into smaller tasks, the time it takes to complete the overall task does seem to be more consistent, because if we go back to the graph, the blue line is very wobbly, there's no chunking, but when you get to the three that are chunked, it does appear to have a more consistent trend line. And that's my presentation.